Welcome to section 3-4. We are going to be graphing polynomials again. So we're jumping back to the concepts of 3-2, but now they will be unfactored. So we need to talk about how to get them factored and use the skills we learned in 3-2 to proceed. So before we do that, I want to talk to you about this concept in the category of real numbers. So if I take the number, let's say 6, and say, tell me factors of 6, you might say, well, 3 and 2. And I would say, well, how do you know that 3 and 2 are factors and not, say, 4 and something else? And the answer is that we know that 3 is a factor of 6 because 3 divides into 6 evenly with a 0 remainder. But 4 is not a factor of 6 because 4 does not divide in evenly. If we divide that in, we get a remainder of 2. So the way that we figure out if something is a factor is through division. Now, not only that, but say I took 6 and I said, hey, 3 is a factor. What's the other one? The way that you figure out what the other factor is through division. So you take the 6, you divide by the factor that you've found, and you confirm that it's a factor by the remainder being 0, but your answer is then the second factor. So we're going to use this principle with polynomials. We're going to take a polynomial, and first of all, the directions are going to say graph. But in order to graph, what we always do first is we look at x and y-intercepts. So the x-intercept, we take 0 and plug it in for y. And here's where we come to the issue of factoring. Because the way you solve a polynomial set equal to 0 is you factor it. So what are the factors of this polynomial? And the answer is exactly like with the 6. Well, if we could find 1, then we divide it in, then the answer would be our second one. So how do we find 1? Well, the answer is you need to do division and get a remainder of 0. So this is where synthetic division is going to come in handy. We're going to take this polynomial right here and we're going to set it up for synthetic division. So I've got coefficients of 1, 2, -2, -3, and 2. Remember to add in 0 if you're missing any powers. So I'm going to draw my ledge here. And then the goal is that whatever I divide in, I get 0 at the end. So the question is, well, what do I put in this place to get 0 there? Well, that's a great question. And the rational root theorem is what helps us determine what that's going to be. So let's remember what that says. The rational root theorem says possible roots of this, or factors. When I say roots and factors, that's kind of a similar idea. The roots of this are going to be divisors of that last number, so plus or minus 2 and plus or minus 1, divided by divisors of this coefficient up front, which is plus or minus 1. So we actually have limited options. We have 2, plus or minus, and 1. And those are the only, if something's going to give us a 0 here, the rational root theorem says it's going to be one of those numbers. So we use guess and check method to figure out what this is. And you choose one and you try it. So I'm going to choose positive 1 because that's an easy place to start. And I'm going to do synthetic division. Now this is where synthetic division comes in really handy because it's faster than long division. You can use long division, but it takes more time. And since we're guessing and checking, we may have to do this multiple times. So I'm going to go ahead and use synthetic. The 1's going to drop down. The 1 times the 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -2 and 3 is 1. 1 times 1 is 1. Negative 3 and 1 is negative 2 and negative 2. And I got lucky on the first guess right there. Okay? And I got 0. So this is the remainder. If you don't get 0, you erase it and you try it again with a different number until you get 0. So what does this mean? Let's remember the format from our division problems. This means that my answer is going to have a constant term of negative 2, an x term of 1, an x squared term of 3x squared, and a cubed term of 1. So this is my remaining polynomial. And if you recall, the way that we figured out what that number is we set our divisor, the polynomial we're dividing in, equal to 0, and we got that answer. So how do we figure out what the original factor was? Well, you just do this backwards. You set it back equal to 0. Subtract the 1 over again, and you get the polynomial that you started with. Which, as we've said, because we got a 0 here, that means that this is a factor of the original polynomial, as is the answer. So what we've done here is we've factored our original polynomial right here. Pretty cool. Now, we can set each quantity equal to 0 now and solve. But what happens when you, so obviously 1's going to be a solution, but what happens when I set this equal to 0? Well, I have to factor it again, and I have to go through the same process. So before we do all that, I'm going to go ahead and factor that again, and how I'm going to do that is use synthetic division. So again, the constants come down, so I've got 1, 3, 1, and negative 2, and I'm going to draw my little L bracket there, and again the rational roots theorem says that my options for numbers out front that are going to give me 0 here are divisors of this last number, so plus or minus 1 or 2, divided by divisors of this number, plus or minus 1. So my options are the same with this problem. It doesn't always occur the same, but it is in this case. And so I'm going to guess. I'm going to start with 1 because that seems like a good place to start. 1, 1, 4, 4, 5. So you can see, obviously, this is not going to happen, okay? So that means I guessed wrong, and we're going to try a different guess. So I'm going to try 2. 3, 4, 5, 10. And what I'm noticing is whenever I have positive numbers out here, I'm getting really big numbers, and I'm getting farther away from 0. So I'm going to go ahead and try a negative number. That might be the ticket. 1, negative 2, negative 1, 2, and 0. There it is. Okay? So let's see what this means. Well, my remainder is 0. My constant term is negative 1. My x term is 1, and my x squared term is 1. So this is my remaining polynomial. And how did I get this guy? Well, I had set x equal to negative 2, and I want it to be equal to 0. I want to undo what I did to find that. So that factor is going to be x plus 2. And I've got, don't forget this guy, because he comes along for the ride. All right, so what I'm doing is slowly, with each process of synthetic division, I'm breaking this into small linear factors. And then once you get down to a quadratic, you can deal with this. Now, sometimes that's going to factor, and sometimes it's not going to factor. So in our case, I'm going to get x equals 1, x equals negative 2. These are x-intercepts, by the way. That's what we're finding. And when I set this equal to 0, it doesn't factor. There's nothing that multiplies to give me negative 1, but adds to give me positive 1. So I'm going to have to run this through the quadratic formula. So here we go. So I've got a negative 1 plus or minus the square root of 1 squared minus 4 times A times C all over 2 times A. Negative 1 plus or minus 1 plus 4 over 2. So this is going to be negative 1 plus or minus the square root of 5 over 2. Okay, and so those are my other two roots. Negative 1 plus root 5 over 2 and negative 1 minus root 5 over 2. Right there. Okay, and then depending on the original problem, it's either asking you to find the x-intercepts or it's asking you to graph the whole thing. I think if I remember correctly, in your homework, the ones that come out with quadratic formula like this don't typically ask you to graph. The ones that come out even do, but it doesn't matter either way. If it does ask you to graph, this is simple enough. You're going to find your y-intercept as well. So I'm going to come up here to my original problem. I plug in 0 for x, and I'm left with 2. So plug in 0 for x, and I get y equals 2. And then I'm going to draw my graph and plot some points on here. So y equals 2 is right here. My x-intercepts are 1 and negative 2. And then my only question is, what is the decimal approximation for these roots? So let's go over to class calc. Negative 1 plus root 5. So negative 1 plus the square root of 5. And then we're going to divide that by 2. Whoops. Let's do it this way. Divide it by 2. All right. So I'm getting approximately 0.62 for that one. So 0.62 is where in here. So let me change my scale. I'm getting some pretty small numbers. So let's call this 1, this 2, and 1, 2, 3, 4, 1, 2, 3, 4. So here we go. Let's remark. Negative 2, 1, and then at 0.6 is just a little bit over a half. And let's go figure out what the minus root's going to be here as well. So change this to a minus, and that's going to be negative 1.6. Negative 1.6 is around here, and these are all single roots. So this thing's going to just snake through all of these guys. And this y-intercept is probably not a maximum, so let's draw it this way. It's kind of a wonky drawing, but you get the idea. That's roughly right. Okay, and that's how you do a graph. All right, let's take a look at another example and see if we can get some extra practice doing it. What I would suggest is, if you feel like you're getting the hang of this, when I write down the problem, pause and try to do it on your own before I do it. And see if you can figure out what these are, and then check your answer with a video. So here we go. We're going to, directions would be to graph. So I'm going to go x-intercepts first. I'm going to set this equal to 0. And I'm going to factor this. So synthetic division, 1, 3, negative 4, negative 12. Now, what are my options? Divisors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. There's a lot of them. There's plus or minus 6, and then there's plus or minus 12. So lots of options. Hopefully one of those smaller numbers works. Let's check it out. I'm going to start with 1. Nope, that didn't work. Okay, let's try -1 while we're here. So -1. No, that didn't work either. But I feel like that might have been closer. So when I move to 2 as my option, I'm going to try -2 first. Oh, there we go. That one works. So what does this mean? That's the remainder. The -6 is the constant. The 1 is the x term. And the 1 is the x squared term. That's one of my factors. And then this guy is when I set x equal to that number and get it back set equal to 0, the way it started when we were going the front direction, that gives me a factor of x plus 2. Now, because this is only a cubic, I only have to do synthetic division once because I'm already down to a quadratic. And this one happens to factor, which is nice, x plus 3x minus 2. You can use the quadratic formula on it every time if you choose. You'll get -3 and 2. And this gives us x-intercepts of -2, -3, and 2. And our y-intercepts are, if I plug in 0 for x, that's going to give me -12. So here we go. Graphing -2, -3, 2, and -12. We'll call this -12. Okay? They're all single roots, so we're just going to snake through all these. And that's our graph. So I think this is pretty cool because up until now, for the most part, when we have taught you a technique for something, there are some problems that this doesn't work on, and we have to say, well, you know, you do this for some of them, but it doesn't work always. This is one of those things, like, we're starting to step into areas of math now where I can give you a technique and it works for everything. Anything that will factor with real numbers will work with synthetic division. So this is a pretty powerful tool. You can now factor anything you want with with all the methods you have. Now you can still use grouping. You can still use greatest common factor. I would definitely look for those first. But then if those don't work, if they're not available, then I jump to synthetic division. So again, tonight for homework is just going to be a bunch of graphing using synthetic division, the quadratic formula, and then drawing some pictures. I will see you for the next section.